Hi, Justin. Thanks for sending your question. I apologize that your question has not been answered in a timely manner. We do have tutors here from 4 p.m. to 10 p.m. Sunday through Thursday. So if you do send another question during that time, we'll make sure to respond to you right away. Let's go ahead and take a look at the question that you sent. It looks like we're trying to find all the roots of this cubic equation here. And we're supposed to do it using the Rational Zero Theorem, Descartes Rule of Signs, and the Theorem on Bounds. Just a brief review because that's a lot of theorems. Descartes' Rule of Signs, we're going to look at the number of sign changes in f of x and f of negative x. So let's go ahead and do that. The number of sign changes in f of x, which is my original function. Let's see, I have positive, positive, nope, to positive, nope, positive to negative. Okay, it looks like I have one possible positive real root. So looking at the number of sign changes in the original function will give us the number of possible real roots, or possible positive real roots, And then I'm going to insert negative x in instead to examine my number of possible negative real roots. So let's figure out what that looks like. If I input negative x in here instead of x, it looks like all of the exponents that are odd will change sign. So I get negative x cubed plus 19x squared, that negative will go away there, minus 8x minus 5 is equal to 0. Let's take a look at this one. We got negative to positive, so there's 1, 2. So there are two possible negative real roots. So that's what we're looking for. Now let's go ahead and figure out our possible rational roots using the Rational Roots Theorem. The Rational Roots Theorem in English basically tells us, take all the factors of the number that doesn't have an x on it, take all the factors of the number in front of the highest power of x, stick all the factors of this over the factors of this, and those are all your possible rational roots. So let's go ahead and factor negative 5 and 6. Meaning we're factoring the numbers from our original function up here. So factoring 6 and 5, whoops. All the possible factors of 6, let's see, I can multiply 6 and 1 together and 2 and 3. And I'm just going to stick a plus or minus in front of these, since I determined that I have both positive and negative real roots. All possible factors of 5, just 5 and 1, easy peasy. Now I'm going to take all my factors of 5 and put them over my factors of 6. So all my possible rational roots, which includes integers, are going to be, let's see, we got 5 over 6, plus or minus, of course, 5 over 1, 5 over 2, 5 over 3, 1 over 6, 1 over 1, 1 over 2, and 1 over 3. So lots of them in this case. So when we're solving equations without technology by this method, it's pretty much just a guess and check thing. Since I know I have more negative real roots than positive real roots, I'm going to start with a negative one because my chances are better there of finding a 0. And I'm going to pick an integer because they're easiest to divide out, and I'm going to pick one that's somewhere in the middle. In other words, I already know 5 is an upper bound on my roots because that's the highest root I have. So I'm going to pick something lower, and then if I need to, I can apply the bounding theorem. The bounding theorem tells me that if I try to divide out one of these roots using synthetic division, and my array of numbers I get on that row at the bottom, if all of those numbers are positive, then my roots go no higher than that number. And if all my roots alternate signs, then my roots go no lower than that number. We may or may not need this. I'm going to try -1. So let's go ahead and divide this out using synthetic division. 6, 19, 8, and -5 are going in the box here. I'm going to make a little box for my remainder. Drop down the 6, multiply. I get -6. 19 minus 6 is 13. -1 times 13 is -13. 8 minus 13 is -5. -1 times -5 is 5. So we got lucky in that case. We just found a real root. So one of our roots, let's go ahead and keep track of them over here, is x equals -1. Let's go ahead and write our new equation, which is dropped down to a quadratic, which we can solve by traditional methods now. I don't need to mess with all this nonsense anymore. I'm not even going to try to factor this. I can't think of anything off the top of my head that multiplies to -30 and adds to 13. So we're going to rely on our handy-dandy quadratic formula. So x is going to equal -b plus or minus the square root of b squared minus 4ac over 2a. That simplifies to -13 plus or minus the square root of 169. Then these negatives will cancel, and I will get 4 times 5 is 20 times 6 is 120 over 24. And again, this will simplify. Lots of arithmetic here. To the square root of 289 over 24. Square root of 289 is 17. So my other x roots are x equals -13 plus 17 over 24. Whoops. That turned into a 24. It's supposed to be a 12. My brain was moving too fast and I did the multiplication in my head before I wrote it down. So let's go ahead and fix this. This should be a 6. I apologize. This will be a 12 and this will be a 12. There we go. So our roots are -13 plus 17 over 12. Which will simplify to 4 over 12, which is 1/3. And x equals -13 minus, using the other sign, 17 over 12, which will simplify to -30 over 12, which is equal to -5/2. So we now have our two negative roots and our positive real root, and these are all of our roots. And this is the final answer to your question. Thanks again for your question, Justin, and I look forward to answering more of your questions using Snap Math in the future.